Here we go to Tim Bell, who's in Canterbury.
Right. Hi. Am I coming through okay?
Hello.
Yep. Hello. Yep. I heard a vague hello there. I can see Mike and Fran sitting up there at the front. Hi, Mike. Fran? Okay, cool. So, yeah, nothing like being on halfway around the world or a quarter of the way around the world to make things a little complicated. But what I wanted to do today is just talk a wee bit about how Unplugged has been going with the new school curricula around the world, because there's been some big changes over the last year. In particular, the UK has just introduced computer science to primary schools, and Australia is about to, and New Zealand has made some moves, and other people. And one of the things I've found is that the Unplugged project has really resonated with people, particularly in primary schools, where they say, well, what on earth do? We have to teach computer science. And there's some stuff for programming, but it turns out that the Unplugged approach is really empowering teachers, because it doesn't crash. You don't have to install it. You don't have to worry about it embarrassing you in the middle of a session, all sorts of things like that. And so I'll talk a bit about what's been going on there. But just by way of background, you may have realised that one of the big memes at the moment that's happening is code. In fact, we're in Code Week at the moment, and President Obama has been promoting the Hour of Code. In fact, our own Prime Minister has done that, and I'm sure people around the world have been doing that. And in some ways, this isn't amazing, because the idea of coding is exactly not what computer science is about. It's the nuts and bolts and so on. And so in some ways it's a bit of a smokescreen, but in other ways, and when you read what the Hour of Code people really want, they actually really want to get people into computer science, but it's code that attracts people, and so they're using that as kind of a bit of a hook. But there's all these organizations that use code. And I mean, how many people here have had anything to do with any organization that's got code in the name, just out of interest? I can see your hands if you want to raise any hands. No, we're all on. Oh, yep, a few. Yeah. Cool. Yeah, so, and, they cover all sorts of groups and demographics and so on. But of course, I'll quote one of my favorite quotes. This got so much mileage from it, from Mike, that computer science is as much about programming as astronomy is about telescopes. It actually goes on to talk about other things as well, test tubes and whatnot. But this single quote has been so valuable in getting computer science introduced into schools, because as soon as you say it to teachers, and particularly administrators and principals and people like that, they go, well, hang on a minute, I thought that was the only thing it was about. And you go, nope, and they totally get the analogy, because astronomers are always buying telescopes and building better telescopes, and asking for money for telescopes and launching telescopes into space and all that sort of stuff, and everyone completely understands that most of them don't care about it. I mean, maybe there's some telescope geeks around who just love using telescopes, but and don't really care about the astronomy, and as we get in computer science as well. But that's been really useful for getting straight to the point. And so one of the things that I often do to lead on from that is to say, well, programming is just making software. So here in this slide here, I've got a simple interface. It's a text box and a button. It's probably the most popular interface in the world. How many people have used this interface this week? Is that of interest? Yeah, okay. So Google are making all their money largely off a text box and a button. Now, that's not hard to write a program to put up a text box and a button, and it's not that hard to write a program that if someone types it in, you just go through every web page in the world until you find the thing that you're looking for. The only trouble is that the response time would be, I don't know, years. I've never calculated it. I don't think Google would succeed very well as a search engine if that's how it was done. And so this is another thing that can really get people thinking, is to point out that computer science is where we, instead of just writing the program, we need to make sure it's fast, and we need to make sure it's efficient. I mean, Google worry about how much carbon they're putting into the atmosphere because of all the warehouses and that of computers they've got. It needs to be reliable, in that, when data is transmitted, when stuff fails, the system still appears to be working. It needs to be secure, because no one wants their searches shared with someone else. It needs to be easy to use. We've got interface issues. It needs to be scalable. So if you suddenly get 10 times as many customers, you can deliver it to 10 times as many customers. You don't want to take 100 times slower just because you've got 10 times as much to do. And even things like intelligent, systems and so on. So, trying to get across this idea, and to me, one of the main ideas of getting computer science into schools is not that we want to turn kids into computer scientists or have them sort of much better prepared for university necessarily, but just that they actually know what it is. Because the biggest problem we've had certainly in schools is that if I go into a classroom and say, what's computer science, then until recently, I'd get very blank looks, and people go, I don't know, maybe fixing computers, eating pizza, things like that. And so one of the big goals has been just to get people interested in that. Now, I showed this last year, and I'm not sure how many people were here last year, but one of the things we've developed is an online version. It's sort of unplugged in that there's no programming to get across the ideas. And so one of the concepts taught in New Zealand schools is tractability, and we really want kids to interact. I mean, one of the principles that we've always had with Unplugged is kids, you roll up your sleeves, you get involved, you don't tell them what to do, you just give them a problem and ask them to roll up their sleeves and try and solve it. This is just about tractability. How do you illustrate tractability to someone who's not that enthusiastic about maths or something like that? And so this is the travelling salesman problem. What's the shortest route around these 7 cities? Or, in fact, the cool thing is we've got a local company here that makes millions of dollars solving this problem for companies overseas. So it's actually quite a local economic benefit that we know, well, we can't solve it, but we can find near optimal solutions. So this takes about half a minute to solve for 7 cities. And I ask kids, how long will it take for 14 cities, twice as many, or 14 courier drop-offs? And the answer inevitably is about a minute, maybe a bit over a minute, or those that think it might be a bit tricky go 2 minutes. And of course, when we crank it up to that for twice as many cities, it's actually 9 years instead of half a minute. This is exponential growth at work. And so then I asked, well, what about 21 cities? And then when they twig on, they'll still say, thousands of years, tens of thousands of years, things like that. The interesting thing is that it actually, it's going the wrong way here, that actually turns out to be 3,800 million years. And then we can explore things like, well, what if the computer was 1 million times faster? It doesn't actually help you if you've got 21 courier parcels to drop off, that doesn't actually help. And what if you had 1,000 computers that are 1 million times faster? Then it's only going to take 3.8 years to work out the best way to drop off these courier parcels. And so the kind of the humour and just the ridiculous extremes you get with this, become very obvious, and it provides a really good point for interaction. But one of the really old systems that we had is, of course, the parity trick, which is just an error correction code, and there's lots of error correction codes around, and we get students to explore these. And again, what's called constructivism in education, you don't tell them how it works, you just show them the problem, you show them maybe being able to solve it yourself, in this case, being able to work out which card was flipped over, and then they try to figure out why. And so, for this diagram, this picture here, that's 100 cards there. One of those was flipped over about a year ago by one of those girls. And once the audience understands how parity error correction works, then they can actually point to the card that was flipped over. Then the whole point of error correction, when a file's been transmitted and so on, becomes a lot clearer. So with the travelling salesman, what we're doing is we're showing kids something that they might have thought was easy. You just get the computer to try out all the possibilities, and when it finds the best one, then it's finished. And this is something that you might have thought was impossible. The data's arrived, some random bits have been changed. Can you figure out which ones were changed and change them back to how they were? And that's part of the excitement, is just to expose them to these things. And computer science is full of paradoxes. It still intrigues me that one of the best sorting algorithms, quicksort, works really badly if you give it a sorted list. That hashing works best if you give it totally random input. All these kind of things that are just not what you might expect. So hence the Unplugged program has become really popular. Here's a couple of 11, 12-year-old girls. They're actually doing Shannon's information theory prediction, which really is just a guessing game. What's the next letter going to be? And the ones that are hard to guess, those are the high information content letters, and which leads to compression and finding patterns in text and so on. But it's a game that they find very engaging. So we've, the Unplugged project has got all these games and activities and so on. But then enter new school curricula. Excuse me. So for us in New Zealand in 2011, we got computer science, and what I call computer science, into the school curriculum just for the last 3 years of the curriculum, which is actually and it's not compulsory, but it's become quite popular, and it's for the years that actually count for credits. Now, the interesting thing that's happening now is that that's starting to telescope down, because so those ones I've got highlighted there are computer science that is done for about 15-year-old students. But the teachers, now that they've taught it for a couple of years, they're going, actually, this is easy enough, and particularly with some of the Unplugged stuff, that I might as well do it with students, 2 years before this, so that when they actually get to the assessment, they've actually been thinking about it and reasoning about it, and then they just need to get a bit more formal for the assessment. And in fact, I'll talk about it a wee bit later, but we're now looking at moving that down into primary schools in New Zealand. And one of the interesting things is it's turning out it's way easier to teach these concepts to primary school students than it is to high school students. High school students have got a lot more at stake. I mean, not only grades, but also self-esteem if they look silly in front of their friends and things like that, certainly in New Zealand, and I suspect in a few countries. And so, whereas the primary school students will just give it a go. And I know, Mike, you had a lot of success with primary schools and so on, and initially when we moved it into high schools, I thought, well, it's going to be even easier, but it's the other way around. It's the primary school students that are just open, and we actually want to try and maintain that openness. But unfortunately, there's a few things like hormones and things that kick in as well that we're kind of working against, so it can be a bit of a challenge. So in September this year, the United Kingdom introduced a new curriculum where every kid from the very first year of school, 5-year-old kids, 6-year-old kids, learnt computer science. And again, they very deliberately kept, well, in fact, they've called it computing, but it is essentially, there's a bit of programming in there, but quite a bit of what we would call computer science. And that's where a lot of teachers have really latched on to the unplugged material, because they can do a whole lot of things that they know is real computer science, but the kids can just really engage in it. The programming that's done, by the way, a lot of countries, well, several countries do programming for 5- and 6-year-olds, but you'll find that it's very, very simple. So, in a Turing complete language, you'd typically have sequence and selection and iteration as your main constructs. And at the junior levels, they mainly just do sequence, so a sequence of instructions. But there's some cool languages around, very motivating ones for kids, where they're just putting together sequences and getting used to the idea that you're giving some instructions in advance to a machine, and once you press the go button, it's going to do all of your instructions, and instructions further down the list, they mean something different after the earlier instructions have been executed. So even the very simple systems, there's quite a bit of abstract thinking that students need to engage in. Australia was going to move to a new curriculum next month. The government's getting slightly cold feet in that there's been a report saying maybe it shouldn't be done exactly how it's been proposed, but I was talking to some colleagues this week and they said they're treating it more like an air pocket, that when an aeroplane hits an air pocket, you just put a bit more power on and you'll get out of it quick enough. So there's certainly the companies are really pushing this very hard. But again, this is from foundation, which is the very first year of school onwards, and I've just highlighted things to do with, say, data representation. So you can see it sort of just goes from the idea that computers can store pictures and symbols through to how is that done using binary representations and so on. But there's things in there on, there's another one here, on interface and evaluating interfaces, and there's things on algorithms, sorting and searching algorithms and things like that. But lots of opportunity to explore some of the ideas around computer science, as well as just gradually build up quite a bit of experience in programming. Estonia famously was teaching programming to its first year introductory students, and again it turns out when you go back and look at what they really did, it's using a system which is mainly just learning sequences, which is great. When you look at the cognitive development of young kids, that's actually quite a bit, and in particular when you're talking about rolling something out to a whole school, and a lot of the work we've done up to now is for gifted classes or self-selected groups that want to do more computer science, or so when you're rolling it out to an entire curriculum, you have to have something that even the weaker students can use. I've been involved in a pilot in Australia where they took 20 schools, I think it was, ranging from elite private schools with every resource you can imagine, through to special needs schools where the kids had severe disabilities, and all of them managed to put together a program that was meaningful to the kids. And once again, Unplugged provided a really good resource. So essentially they're using motivating programming systems that have essentially look like games and challenges and so on, and then mixing that with ideas from Unplugged where students can engage with some of the other ideas. So lots happening, and lots of other countries are gradually engaging and piloting and experimenting and all that sort of thing. I was in France recently where they're looking at what should they do, and one of the interesting things was I was interviewed by a guy called Emmanuel Davidenkoff, who is kind of a well-known radio interviewer who asks tough questions. And he wrote this article, which I've put through Google Translate for those who don't read French. And it had three sort of main paragraphs. It said, $5, that's the cost of equipment used for Unplugged, basically. And then $14,000, that's how much people are spending to send their kids to a school that doesn't use high tech. And then 700 million, how much people are thinking of spending on devices for schools. And he was really, I mean, after we'd done some Unplugged stuff there, he was really convinced that this is a really bad idea to spend all this money on, if you want to get kids up to speed with computer science and the basic concepts, then you don't just go and buy lots of equipment and all that sort of thing. And in fact, he was kind of advocating, just spend $5 and you'll be right. So again, really neat to see Unplugged having influence there. And then just recently I gave a workshop in Poland. Everyone signed this board at the end of the day. There's quite a strong movement there who are really interested in primary schools. And again, they see Unplugged as the thing that teachers can get their head around. They can get comfortable with that sort of approach because it doesn't have to involve computers. And in Australia, with the curriculum coming up, I've been involved in some pilots in Victoria and Sydney and Tasmania. And again, so, just really interesting to see that the teachers are really enjoying it. And I think, unlike the high schools, there's a lot less pressure on the teachers. So as long as you give them fun things to do and interesting stuff to explore, they'll be up for it. And by the way, I mentioned the Hour of Code because this is Code Week. When it's an American organization, but there are literally millions and millions of people encouraged to do 1 hour of programming this week. But if you go to their website, they say, well, if you don't have a device or internet, try Unplugged, and then there's some ideas. None of them directly from the Unplugged project, but the two of them are derived from what we've done, because of course Computer Science Unplugged is open source, it's free for people to use and adapt and so on. So it's just kind of neat to see the Unplugged thing appearing even in something that ostensibly is, we should all do some programming, but well, maybe Unplugged's interesting as well. I see, I took that screenshot at the start of the week and I see we had 27,000 participants already, so that's pretty good. Now, this article came out last year, and it was April 2013, and it actually kind of got my blood boiling for a start, because the heading kind of says every 8-year-old should be learning to code, to program. And the question is, well, is this a good idea? And should, because in some ways it puts them straight on the computer, all that sort of stuff. Now, in actual fact, when you read it, there's not a lot of strong arguments in the article about why that should happen. It just more says it is possible, and it's actually kind of advertising Tinker, which is a new system for teaching programming. There's so many systems around now. In fact, here's some of the ones that are around. So Scratch has become very popular. Snap, Tinker, Blockly, Bebop down the bottom there is quite widely used in Australia. They're all systems that let kids get into the ideas of programming without actually sort of having to, particularly they avoid syntax errors, they work in a world that a kid can understand, which generally they involve movement, turtle robot kind of movement. But we actually did a bit of research into this business of, should your 8-year-old be programming, basically. In fact, we published a paper recently with that title. And it turns out if you think about programming at primary school, there's a few issues that make it quite important. So one of them is that it's important for kids to discover their strengths before they're 12 years old. What happens at 12 years old? Well, not just on their 12th birthday or their 13th birthday, but as students enter adolescence and go through puberty and that, they really do start to view the world differently and think differently about things. The opinions of their peers often, has more sway than logic. And so if you can, before the age of 12, if you can get them to think, gosh, I can do computer science, programming is something that kind of makes sense to me, then that will go through with them through their teenage years. But if not, and we're finding this in New Zealand where we have computer science available to teenagers, is that it's still kind of hard to get the kids into the class because the kids think, well, I don't like computer science, my friends don't like it, so therefore I don't like it. And also, of course, parents form stereotypes as well. But before they're 12 years old, and I mean, how many people here have worked with pre-12-year-old kids? Just so I can see your hands here. A few of you have worked with kids younger than 12. Yeah. they're just wide-eyed and enthusiastic, aren't they? And you know, if you ask them a question, they'll try and answer it, and they don't care if it's the wrong answer, but they really want to have a go at it, and they'll explore possibilities. And actually, around about 10 to 12 years old, the brain development is huge at that age. Some people say that it's probably the fastest development of the brain, short of when they're actually in the womb. And so it's a time when they really can cope with all sorts of stuff. It's well known if you're going to learn a language, it's much more difficult after the age of 12. That kids under 12 who learn a foreign language will do better. And while the connection between foreign languages and programming languages and the language of computer science hasn't, been drawn in a strong way, obviously there is some connection there as well. Mentioned, self-esteem can drop, particularly for girls, and of course in computer science we really are missing out on female representation. Now the other thing about having stuff at primary school is that we don't want to teach programming, and one of the trendy things that's come around is the idea of teaching computational thinking, which I think in some ways, and I think back to, read some of the stuff that Mike Fellows was writing decades ago, it's kind of captured a lot of those ideas, but it's finally caught on a wee bit. And it's the idea that, we actually want to design something where we're worried about the process. What's a process that will solve this problem? Not what's the solution to my particular problem, but what's the general process that's going to happen? And one of the other things, of course, which I've got there is when you're thinking about programming, it's not just writing something for the computer, it's actually communicating with humans, because people who work on software engineering programs, that has to be read by someone else. And sure, the computer will execute it as well. So computational thinking has become quite a hook. Now, for me, actually, the thing that's really been driving this is this quote that I really like, which is, the greatest tragedy I know of is so many young people never discover what they really want to do. And over, I come across kids doing computer science who got into it accidentally. They got into it because their boyfriend was doing it and they decided to sit in on the class, or they had to take it as part of something, and then they discovered that they absolutely loved it. Some of the best students we've had have been in that situation. So one of the things we've got is that, in New Zealand, our curriculum covers topics like algorithms, programming languages, and so on. And one of the things that we've found is that the teachers have been scared. We get a phrase like formal languages. If you Google formal languages, you get some pretty scary stuff back. So one of my catchphrases, there's the girl on the right there just behind me, once asked me a question. She said, "Why do you use such big words for such simple ideas?" And that was brilliant. I use that often for teachers, and that's really helped them a lot, because we use all these big words, finite state automaton and sorting algorithms and all that sort of stuff. I mean, even the word algorithm is quite scary for teachers, but it really helps them to realize that, yes, these, again, using the unplugged ideas, we can get these things across quite easily. Just to finish, one of the things that we've ended up developing is this computer science field guide. It's open source, like everything that we've been working on. We've just finished, as in we've covered all these topics a few weeks ago. Last year, about half of it existed. It's got videos, things that students can interact with. We really want to engage students on these topics, so you're more than welcome to have a browse around there. It's aimed sort of more at teenagers. In terms of what's happening, what we're up to, so that field guide is more or less complete. It's kind of like, Unplugged for teenagers. The Unplugged site itself, we're just in the process of revamping at the moment too, because now that Unplugged it was originally designed for outreach, for someone like myself could go into schools and have fun with kids and so on. But now, of course, it's being used for teaching, and so it needs to be mapped onto curriculum so teachers can just figure out which activities they'll use, and it needs to have a little bit of assessment so teachers can figure out if their teaching was successful with the kids. And then the other thing that we're doing is putting on lots of workshops for teachers, helping them get up to speed with it, and certainly it's a lot of fun, and I think the teachers are finding it quite empowering. So I've put up a bunch of links there to some of the stuff that we've been doing, that's sort of some of the things that have been happening at the moment, and I don't know if have we got time for questions?
Yeah, let's give Tim a big hand. Some couple of quick questions before we go on to the next presentation. Anyone? Yeah.
Here, Mike.
Hey, Tim. Who are you working with
Hi.
in Australia on the curriculum stuff?
So I'm not working on the curriculum, but in Australia, there's a bunch of organisations that have said we like the idea of the curriculum and we'd like to pilot it and so on. So in Victoria, it's the VCAA, Victorian Curriculum something or other Association, who dictate the curriculum for the schools, actually. They're the ones that piloted with about 20 teachers. Tasmania, the Catholic school system have decided they want to really get into it. And then in Sydney, I mean, Google themselves are really enthusiastic about the whole thing, but also there's a university there, ACU, that have been training teachers. Yeah.
Right. Thanks.
Tim, hi. It's too bad you're not here. Can you say a few words on what's the process of training the teachers? How long? How many days? How don't know, how open they are to this idea? Is it forced upon themselves?
Yeah, that's a really good question. So the way that it's worked out in all of the countries that I've been involved with so far is that it's kind of voluntary for the teachers to get involved, but more and more they're being sort of given more pressure to get involved. We don't have enough time to do these things properly. And quite frankly, in New Zealand, the funding has been awful because what happens is people say, we need more funding to get computer science in the schools. And they go, oh, yeah, no, that's all right. We've just put up this many $1 million to put in broadband. So, yep, or we're getting iPads for all these schools. And so, yes, you've got computer science. And so it's been very, very hard to do that. But industry have put a lot of money into this. So we just had a workshop last week. And one of the reasons that I can't be there, unfortunately, is that we just had 120 teachers through. They were paid to fly in from all around New Zealand, 3 days, all expenses paid, all accommodation paid, all food paid, and we did 3 days non-stop of. Now, so it's under the CS4HS banner, which Google runs this all over the world. Usually it's CS4HS says, here's some fun ideas in computer science, let's just explore them and maybe you'll use some of them. Our one is really focused. It says, here is everything in the curriculum. We're going to show you how to teach everything in the curriculum in 3 days. We won't show it to you thoroughly, but we'll get you started, we'll point you at resources, we'll show you some other courses you can take and so on. And it's amazing how far, some teachers get a long way in that and then they go and explore it in their own time and start teaching it. But really you need a lot more time than that. We've got a course in New Zealand that teachers take, it's 150 hours. That one's more like enough for them to get up to speed. But they have to do it in their own time because it's very hard for them to convince management they need to do it because management just say, oh, everyone knows how to use computers.
Okay.
One day we'll get to management and sort that out.
Okay. Thanks a lot, Tim, for joining us all the way from Canterbury. And round of applause.
Oh, thanks
Tim.
for the opportunity. I appreciate it.